You've done this 1,000 times, right? You grab an Ethernet cable, you find that little port in the wall, and you plug it in. Click. And just like that, you're connected to a whole world of data. It feels so simple, almost like nothing. But have you ever actually stopped to wonder, what's on the other side of that little plastic plate? What is the hidden machinery that makes that simple click possible?
Well, let's pull back the curtain, because behind that port is an entire unseen world. A world that is governed by some incredibly strict rules and really meticulous engineering, all of it designed for just one thing: a perfect, uninterrupted connection.
And this is the blueprint for that world. Now, it might look like just another dense technical manual, but documents like the Saudi Aramco engineering standard here, they're the master plans. They're what dictate how a building's digital lifeblood is designed to be tough, safe, and totally ready for the future.
So, for the next few minutes, we're going to follow the data's journey together. We'll start right where the internet comes into the building from the street, we'll go to the building's digital brain, and then we're going to trace the path all the way through its nervous system right to that port on your wall. Okay, our journey starts at the two most critical spots in any connected building: the gateway to the outside world and the central brain that directs all the traffic inside. First up, you've got the entrance facility, or EF for short. The best way to think of this is like the building's fortified border crossing. It's the one single, super secure point where every cable from the outside world, we're talking fiber optics, copper lines, the whole shebang, is allowed to enter.
From that gateway, all the data travels to the Telecommunications Equipment Room, or the TER. And the standard calls this an environmentally controlled centralized space. And that phrase is so important, because this is not just some closet with a bunch of wires. This is the building's digital brain, where all the really critical switching, routing, and thinking happens.
And these rooms, the EF and the TER, they're protected with an intensity that you probably wouldn't expect. I mean, they're basically treated like high-security vaults. So why? Why go to such crazy lengths? Well, because the risk of something going wrong is just catastrophic. And here is our first just jaw-dropping rule from the standard. Absolutely no pipes carrying any kind of liquid are allowed anywhere near these rooms. Not through them, not above them, not even running inside the walls right next to them. Because one single leak could knock an entire building completely offline. And this just shows you how serious they are. The no water rule is so absolute that even the fire sprinklers have to be special. You know the standard wet sprinklers that always have water sitting in the pipes? Totally forbidden. Instead, they have to use what's called a dry type system, which only fills with water the exact moment it's triggered. It's all to prevent one accidental spray from destroying millions of dollars of equipment. And of course, this brain needs room to grow. Just look at this table from the standards. It shows how much physical space has to be dedicated to this stuff. For a really big building, say 100,000 square meters, the TRM has to be over 8 meters long. That's a huge commitment of expensive real estate, all for the sake of connectivity. Okay, so we've seen the gateway and the brain. Now, let's follow the signal as it travels out into the building's nervous system, this vast web of cables that carries data to every single corner.
Now, this nervous system really has two main parts. First, you've got the backbone cabling. You can think of this as the building's spinal cord. These are the big, high-capacity data highways that run up and down between floors, connecting the main brain to local hubs. And then you have the horizontal cabling. These are like the individual nerves that branch out from those hubs to every single desk.
So let's just map that whole journey out. Data comes in at the gateway, it gets processed in the main brain, the TER. It shoots up the backbone spine to your floor, where it enters a smaller local hub. Then it travels through those horizontal nerves to finally arrive at the port on your wall. It's such a clear, logical, and super organized path. But to make that journey work perfectly, there is one non-negotiable rule for that final leg of the trip. The horizontal cable, the one running to your desk, cannot, under any circumstances, be longer than 90 meters. That's 295 feet. Any longer than that, and the signal quality just starts to fall apart. This rule is what guarantees that the person sitting furthest from the equipment gets the exact same high-speed connection as the person sitting right next to it.
So how on earth do technicians manage all this complexity? Well, with extreme organization. Check out this table. It shows the mandatory color coding for the cable terminations. Orange is for the external lines coming in, green is for the internal network, blue is for those cables going to your desk. It's a visual language that makes finding a problem and fixing it incredibly fast and efficient. It's genius, really.
You see, this whole system is built on a foundation of rules designed for one thing and one thing only: absolute 24/7 reliability. This isn't just about being fast, it's about making sure the network never, ever goes down. And to do that, you have to create the perfect environment. I mean, look at these specs. Temperature and humidity are locked into this tiny, constant range. The AC runs 24/7, 365, no exceptions. The power circuits are dedicated, which means they can't be accidentally shut off by a light switch. The walls even have a 1-hour fire rating. These aren't just rooms, they're technological life support systems.
And here's another one of those little rules that just shows you the insane level of detail involved. False or suspended ceilings, the drop-down ceiling tiles you see everywhere, completely forbidden in these rooms. And why? To stop dust from building up and falling onto sensitive electronics, to make sure there's always easy access to everything, and for security. Every single detail matters.
So who's responsible for dreaming all this up? For designing these incredibly complex and vital systems? Well, that brings us to the human element, the actual architects of our digital connections.
The standard is crystal clear. All this design work has to be done and signed off by a registered communications distribution designer, or an RCDD. These are the highly certified pros who live and breathe every single one of these rules. They are the expert architects who make sure our buildings are wired correctly for the modern world.
And maybe the single most important rule they have to follow is this one. Every system, by law, has to be designed with a minimum of 20% spare capacity. That means every cable tray, every rack, every power system is built not just for what we need today, but for what we might need tomorrow. It is future-proofing, literally built into the blueprint.
So the next time you plug that cable into the wall and you hear that satisfying little click, just take a second. Remember the gateway, the brain, the nervous system, and the hundreds of meticulous rules all working together in perfect harmony just to make that simple little connection possible.
It really makes you wonder, doesn't it? This incredible invisible infrastructure was designed for the demands that we know about right now. But as our world gets more and more connected, what will our buildings' nervous systems need to handle next?